All right, pre-algebra students, we are moving into our next module, and we are going to begin with a two-part lesson about the properties of exponents. So in this part of the lesson, we should be able to develop and use the properties of exponents to solve problems. So we are going to go over the basics of exponents. We're going to talk about three rules today. That's the product rule when we're multiplying exponents with like bases. We have the quotient rule when we're dividing exponents with like bases, and the power rule when we're raising a power to a power. And then we're going to apply those properties to solve some problems. Make sure that you're following along with our guided notes, and let's get started. So let's talk about some basics of exponents. We know that 5 to the third power, or 5 cubed, just means 5 times itself 3 times. That's what 5 to the third means. So in this example above, 5 is called the base, and 3 is called the exponent, or power. So it's called the exponent. We can also call this the power. And we write exponents in superscript. So they're smaller numbers that are slightly above the base. And we know, thanks to our invisible mathematics, that any number raised to the power of 1 is equal to itself. For instance, 8 to the first power, meaning 8 is the base, 1 is the exponent, that would just be 8. We're multiplying 8 by itself one time. And then 50 to the first power would also be just itself. 50 times itself one time is 50. And then we also know that any number raised to the power of 0 is equal to 1. That means 12 times itself 0 times would be 1. And 100 times itself 0 times is 1. I'll get into the specific reasoning about this in our next video, but for now, really important to note, any number or variable, it could even be y to the 0 power, and that equals 1. Any number or variable to the 0 power equals 1. So those are just some of the basics before we get into our three rules. So let's first talk about the product rule. This happens when we multiply like bases. So when like bases are being multiplied, their exponents can be added. This is really cool. So in other words, and I'm using variables here, but I'll give you a more concrete example in just a second. X to the a power, whatever a might be, times x to the b power, remember x and x are the same base, that's equal to x to the a plus b. So for example, 2 to the second power times 2 to the third power would just be 2 to the 2 plus 3 power. You're adding the exponents because these numbers have the same base. 2 and 2 are the same base. So that would be 2 to the 5th power. So here's why that is. Let's say I expand these values here. I know 2 to the 2nd power is just 2 times 2, right? And then I'm going to multiply that by 2 to the 3rd. That's 2 times itself 3 times. But really, when we're multiplying all of these 2's together, we're multiplying 2 by itself 5 times. So there are 1, 2, 3, 4, 5 2's being multiplied together. So that's why the product rule works. And again, this is only when we have like bases. Now let's talk about quotient rule. This is when we divide like bases. So when like bases are being divided, their exponents can be subtracted. In other words, let's just start with variables here. X to the a power divided by x to the b power equals x to the a minus b. The exponent in the numerator subtract the exponent in the denominator. Here's a concrete example. I'm just going to use 2's. 2 to the 5th power divided by 2 to the 3rd power is just the same as saying 2 to the 5 minus 3 power. And that's 2 to the 2nd. 5 minus 3 is 2. Here's why that works. Let's deconstruct these exponents for a second. I know that 2 to the 5th just means 2 times itself 5 times. And then I know 2 to the 3rd just means 2 times itself 3 times. Now, I know that anytime I see 2 divided by 2, that just equals 1, which means I can reduce a 2 in the numerator and a 2 in the denominator. So I'm going to take every 2 over 2 that I see and eliminate it. I'm going to reduce that to 1. This is also reduced and reduced one more time. So what I'm left with is 2 2's, 2 times 2 on the numerator of my fraction. And that just equals 2 squared over 1, which we don't need to write the over 1, we just need to write 2 squared. So that's why the subtraction works in problems like this. And really this just saves us some time, because if you have like 9 to the 15th over 9 to the 10th, that's a lot of y's to write out in a fraction. But we can just take the shortcut, subtract the top exponent from the bottom exponent, and it would be 9 to the 5th power. And now we have power rule. That is raising a power to a power. So when an exponent is raised to another exponent, the exponents can be multiplied. In other words, let's say you have x to the a power, and then you're raising it to the b power, meaning you've got some parentheses here, and you are going to multiply the exponents, a times b. Here's another example. Let's say I've got a variable here. Let's just say y. Y to the 5th times y, or y to the 5th to the 2nd power just means y to the 5 times 2, and that equals y to the 10th. And again, I'm going to explain by deconstructing these exponents. So y to the 5th I know, and I'm going to give myself lots of room for this. Y to the 5th just means y times itself 5 times, right? And then since I'm squaring that value, everything in the parentheses, I'm going to multiply that entire thing by itself. There are 2 y to the 5ths that are being multiplied together. So another y times y times y times y times y. Now if I count up all of these y's, again this is y to the 5th times y to the 5th, there are a total of 10 y's. So really, when I multiply them together, this is y to the 10th power. So let's practice applying these concepts. We're going to simplify these expressions and leave each answer as a number raised to a power. So in problem number 2, I'm given q to the 9th over q to the 6th. So I know that since I'm dividing exponents with like bases, I'm going to use quotient rule, which means I'm subtracting the exponents. This is going to be q to the 9 minus 6 top minus bottom. And I know 9 minus 6 is 3, so my final answer would be q to the third. Now in my next example, I've got a little bit more simplifying to do here. I'm given b to the fifth to the third power times b to the fourth. So I'm going to use multiple properties of exponents here. I know that my first term, b to the fifth to the third, I'm going to use the power rule, which means I'm going to multiply the exponents that I see. This is b to the 5 times 3. And then I'll rewrite what I have left over here. So I know b to the 5 times 3. 5 times 3 is 15. And now I'm given b to the 15th times b to the 4th, which means I'm going to add my exponents. This is the product rule. When I multiply exponents with like bases, I'm adding the exponents. So 15 plus 4, and that would be fully simplified b to the 19th power. All right. For problems just like this, you can try out 1, 3 through 5, 7, and 8. You don't need to try all of them, but just enough so you understand this concept. All right, let's try some more problems like this. Except this time we're going to fully simplify. We don't want any exponents in our solution here. So for number 11, we're given 2 to the third to the second power raised to a power here, divided by 2 to the fifth. So what I want to deal with first is this numerator section. I see there's a power raised to a power. I'm going to multiply those exponents. So 2 to the 3 times 2, multiplying, would be 2 to the 6th. And we're dividing that by 2 to the 5th. Now we're going to use quotient rule, which says to subtract the exponents, 2 to the 6 minus 5. And that equals 2 to the first. And 2 raised to the first power, or any number raised to the first power, just equals itself. So my final answer would be 2. Right, looking at number 12, I've got another problem where I have multiple properties I'm using to solve. A to the second power to the first power times 8 to the 0 power. I know that 8 to the 2 times 1 is just 8 to the second power. 2 times 1, multiplying here. And then we're multiplying by 8 to the 0 power. Now, earlier I said that any number to the 0 power equals 1. So this is really 8 squared times 1, which equals 8 squared, which, when we simplify, 8 squared is just 8 times itself, 8 times 8, and that equals 64. For problems like this where we are simplifying our exponents, try out problems 9, 10, 13, and 14. And let's try 2 final problems. This time we are going to label the following equations as true or false, and we're going to show our thinking through that process. So in number 15, I'm given this equation, x to the 4 to the third power equals x to the third power to the fourth power. So I'm going to be using the power rule a lot. What I want to do to show my thinking is I want to simplify both sides of this equation and see if the left side equals the right side. So on the left side, I know I need to use power rule, which means I am multiplying the exponents, 4 times 3. And then on the other side of the equation, doing the same thing, multiplying the exponents, 3 times 4. And when I simplify, 4 times 3 is 12. So x to the 12th is equal to, well, 3 times 4, it's the same kind of problem. 3 times 4 is also 12. So now that I know the left side of the equation equals the right side, I can say this equation is true. And for problem 17, I'm given x to the 5th power times y to the 5th power times y to the 0 power divided by y to the 3rd power is equal to y to the 2nd power to the 1st power. So now we're using all three rules here to simplify these equations. Let's start with the left side. Y to the 5th power times y to the 0. I could say that y to the 0 power is 1, but I can additionally say that I'm using product rule for the numerator. That means y to the 5 plus 0. That's just y to the 5th power. And again, that is still over y to the 3rd. And now on the right side of the equation, I know I'm using power rule. I'm multiplying the exponents. Y to the 2nd power to the 1st power is just y to the 2 times 1. That's y squared. Now on the left side of the equation, I need to further simplify. I know I'm going to use quotient rule. I'm dividing exponents with these like bases here. And 5 minus 3 is 2. Y to the 5 minus 3 is 2. So it looks like the left side of the equation equals the right side, so this equation is also true. And if you'd like additional practice with justifying your thinking, proving whether equations are true or false, try out problems 16 and 18. So that is it for the first part of our exponents lesson. Make sure that you are trying the additional practice problems, as many as you need to understand the concept. Check your answers with my filled in the blank notes. You can find these in the content library in the Module 2 Notes tab. Ask for support in Math Help Desk if you need it, and I hope you have a great day.